filming?
Filming.
Okay. Okay, well, hello everyone. This is the first lesson. I've given you sort of the introduction to this method, and hopefully it'll work. So here's our first little visual cue as to what today's topic is about. Okay, right there. Can you guess? Anybody? Bueller? Anybody? All right. We'll pan over to the solution while I turn on the lights. Yes, today's topic is algorithms. All right? An algorithm is nothing more than an ordered list of steps that will help you solve a problem. Okay? So it's an introductory topic for a first chapter in our book, so it's not rocket science, but it's important because math is about structure and organization, and we are going to come up with ordered lists organized to solve a problem. So we've got some basic algorithms, right? So your job is to read the book carefully. You're going to read from the beginning to about the start of the homework on page 6, and I'm going to kind of just get you started on what I want you to know for the homework, all right? You'll see that there are a lot of different problems that we try to solve. There's how to get from point A to point B. If you go on Google Maps and look up how to get from your home to the school or whatever, it's going to give you a list of things to do. It's going to say drive 0.3 miles and turn left onto one road, and go 2.5 miles and turn right onto another road. So that's simply an algorithm, all right? So one of the problems in our book is about taking a triangle. So I've got a visual aid here. It's problem number 4 in the book, and they say find a triangle, draw one in pencil and then cut it out. So I've done that, okay? And they say find the median for each of the 3 sides. Well, you probably haven't covered it, but it's actually in red ink in your book if you read down for problem 4. A median is nothing more than a line segment that connects a vertex to the midpoint on this opposite side. So the challenge is, how do we do that with just paper folding? Well, it's relatively straightforward. If we fold point to point like that and just make a little pinch, we'll get the midpoint. So that's the midpoint of this opposite side. And now I'm going to fold a line that goes from here from that vertex to the midpoint. I just have to know where my starting and ending points are, and if I'm careful, I can come up with a fold that goes from this midpoint to the vertex on the opposite side. I can then repeat that by folding these 2 vertices together and making a second midpoint, and then by folding along there to the opposite vertex and folding that carefully, okay? And I've got these 2 fold lines crossing, all right? Now if I do it one more time, we might discover something about this resulting fold. So here I go, vertex to vertex, and I find that midpoint, and then I'm folding it from the vertex to that midpoint. And if I've done it carefully, which I say I'm about at a B+ level here because I'm going fairly quickly, they should all 3 intersect in one point, and they're relatively good, okay? Turns out there's a property that is associated with this. 3 medians all cross in one point that's called the centroid, and the centroid has an actual physical property. If you do this at home, and they say in the book to do this with this type of a triangle where all the angles are less than 90, that's an acute triangle. And you can try it with an obtuse triangle where one of the angles is more than 90. You'll see that not only do these 3 folds always intersect in the triangle, but there's also a physical property about those points being the balancing point, okay? So if I take this as an exact copy of that triangle, like this, okay, and I've marked where those fold lines are in the exact center, this is the exact balancing point for that triangle. So that's the property associated. Now we're doing this, if you read in problem 4, they want you to write down those lists of steps to do. And if we were to write that down, we'd say that maybe step 1 is to cut out triangle. Cut out, this is where acute triangle, if I'm doing it that way first. And step 2 would be to pinch small fold, bringing 2 vertices together. And then step 3 would be fold opposite vertex to pinched fold, for lack of a better name, all right? And then step 4 would be repeat with second vertex. And then step 5 would be repeat with third vertex. And when you're repeating a step until you're done, that's called a loop, all right? So you'll see that you often will have an algorithm that you're doing a certain number of steps over and over and over again until you get to a solution or to get to a completion point, okay? So that's one example of an algorithm, a series of statements that are connected to solve a problem, okay? Pause. Okay, filming?
Yep.
Cool. All right, so this is a short lesson. It's a pretty simple one. They get a little harder from here. The key thing I want you guys to know is that when you're doing your homework, which is up here, it's page 6, 1 through 3 all, then 5 through 19, is that you just think about the steps that you're taking and you write them down. I also want you to come up with your own problem, something from life experience where you've done a series of steps to solve a problem. Come up with your own example of an algorithm. And you can write it down if it's simple. If it's complicated, you can be prepared to talk about it in class. All right, thanks very much.
Ooh, come on, baby, let's